Hey there, it's Max, and this is a little bit of a change up compared to the previous things we've done. The previous exercises have been very simple. They've had a little fill in the blanks and they teach the concepts. This challenge is more so meant to bring that all together. It's meant to be substantially harder and a little bit more interesting. So instead of just one fill in the blank, so you do everything right and that's it. With this, you have to find the vulnerability, you have to exploit it for both a memory leak and for memory, more so of a memory and data editing corruption bug, and then you have to pop a shell with it. So it's meant to be a little bit more complete. When I say real pwnable, it's more like a CTF challenge you would see. It's not going to be similar to an actual like IoT device or real binary exploitation in the real world, but it's meant to be a stepping stone towards that. So now we're going to talk about the actual challenge itself. I think the best way to do that is just look at source code. So within the source code, we have a couple different options, and we can see that within the banner. The first one is we can create a kid, because this is kid management. If only having kids was this easy. You can create a kid, you can view a kid, you can free the kid or kick him out of the house, or you can change a kid. In reality, you can't actually change a kid. So with option 1, we're going to call create kid. Option 2, we're going to print the kid. And so this is going to call a function pointer on a particular structure, and we'll get into the structures and those functions in a minute. But I think seeing a high level of these functions is helpful. After that, we can free the kid, so we can call dump. And then the final option is edit, and edit calls edit kid. So the structure itself has an age of long. It has a char of 20, or a name that is 20 bytes, and they're all characters. And then it has a function pointer. The data structure we're going to be accessing the whole time is one called all kids, and this is going to have a list of pointers to kid structures. When we call create kid, it's going to allocate something of the kid structure size, and then we're going to call fgets for the name, and then fgets and a to long on the age and set that value. And then depending on the kid's age, we're going to write the function pointer for that. If it's under 10, it's print kid younger. If it's older than 10, then we have a different function called print kid, or older kid. For edit, it's the same thing effectively, and the big difference is that with edit kid here, we have a sub option where we have to specify the kid index we're trying to edit. Free kid is effectively the same. We're specifying structure, pointer, and then we're going to free it. We have the actual the functions for printing that we specified up here. And this is just going to be a CLI like we saw with the allocation challenges, where you just interact with it. So if we go to the terminal here and go to modules, FD poison, and challenge 1, we can see what this looks like a little bit more. So maybe start.py, and I always forget to use tmux. So we'll go to continue, and then we'll go up here. Cool, so we can create a kid and ask for your name and the age. We can view the kid, and it's going to ask for the index. And then based upon that, we can see the kid. So we can see it's Maxwell with age 20. We can change the kid, so I can change their name. We'll say Johnny. And then we can do view kid again at index 0, and it will show their age and name once again. And then finally, you can free the kid. Cool. So that's how you interact with CLI, and I think that's good for testing. But for actually interact with this, you want a little bit more. So within this, we have different functions that are built in for you that use pwn tools to do the parsing. For instance, we have create kid, edit kid, free kid, view kid. So I can do view kid and have the index. And notice where we have the create kid one working for you is here as well. So if I do start kid again, and I do continue, and then I go up and view it, we can see it actually prints the kid for us. It has the bytes Maxwell and then hex 20. So it's already doing the parsing for us, which is really nice. Again, this isn't meant to be a class in pwn tools. It's meant to be a class on heap exploitation. So trying to just do a lot of that more annoying, tedious stuff for you. Cool. So I'm going to exit here. I guess we can go back to the screen. Cool. So as a recap, we have a pwnable that you guys need to try to exploit here. You guys need to read the source code, find the vulnerability, find an information leak, figure out how to pop a shell using the FD poisoning technique. Now, if I were you, there's function pointers within the structure we're doing. So I would try to overlap a fake FD or a fake chunk over the top of that function pointer and then call the win function for it. May have forgot to call that out, but here there is a win function that was put in there just to make you guys' life easier. So overwrite the function pointer using the FD poisoning technique with the address of win. Good luck, have a good time.